Hmm. Check. So good evening everyone. So in previous lecture we studied the easy question of DBMS interview questions, and in this session we have to study the intermediate DBMS interview question. So these question test our technical proficiency in the DBMS tool and concept. So interviewer use intermediate knowledge to solve the real problem. They are looking for the hand-on experience with the query optimization and the understanding how database work under the hood. So explain the different type of index and when to use each. So different different types of index. Okay, different type of index and when to use Okay, so this is the question. Different type of index. So as we studied earlier in our DBMS session, so there is two types of indexing: cluster indexing, non-cluster indexing. For the further analysis, we have to see composite indexing and unique indexing and the partial indexing. So the types of indexing are as follow. First one is cluster indexes index. Second one non-cluster. Third one composite. Fourth one is unique. Okay, and fifth one is partial. Okay, so what do you mean by cluster indexing? So let's discuss the cluster indexing. Is cluster indexing physically reorder the data and physically reorder the table data based on the key value. You can only have one per table because the data can only be sorted. Indexing means that you can physically reorder the table's data based on the key value pair, and you can only do once in a table because you can sort the data only once. So physically reordering, physically physically reorder and do once using 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 the key values like this. In non-clustering, create a separate structure that point separate structure. Okay, separate structure that point to the table's row without changing the physical structure. Separate structure pointing mm, pointing the pointing the row without changing the physical order. Okay, in composite one cover the multiple columns and work best when the queries filter on those columns together. Now, composite one is the covers multiple column work best when the queries filter on the. Okay, so simply remember, work on multiple column. Okay, and third one, unique enforce the fast lookup. So enforcing actually it enforcing the uniqueness. So it's enforcing the uniqueness. Okay, and the parcel only index row that meet certain condition. Saving the state. Parcel only row or only index or rows that meet the certain condition. Okay, and saving the space. So different type of clusters and different type of index we use in our DBMS. So first one, cluster index, non-cluster index, composite, unique. So cluster index basically reorder the table's data like sorting. We can only do once in a table. And non-clustering is we create a separate structure that point to the tables and row without changing the physical structure. And third, composite, we work on the multiple columns and best when the queries filter all those columns together. Unique index enforce the uniqueness while providing the fast lookup. Parse only index or rows that meet the certain space or criteria. Okay, So let's move forward. We understand the basic difference between physical cluster and non-cluster index. Cluster index determine the physical storage or data, physical storage order of data table. Think like a phone book sorted last name by last names. Okay. Non-cluster index is like a index at the back of textbook. They point the where the actual data live without changing the book page order. Okay. So how to create a cluster and non-cluster indexing. So let's see the codes. um, mm, Code for this cluster and non-cluster. So for clustering, primary key create a cluster in the index default. So primary key create for the cluster for default. Like then mm, create create table employee. Okay, in which id is int and primary key clustered. Okay, comma, and the name is varchar. Okay, of 100 size, and email is also a varchar, uh, variable character of size of 100. So here is the cluster, primary key created through the cluster, and non-cluster create a non-cluster index email on this. So for the fast lookup, a table may only one cluster index but many non-cluster one, and cluster index are the fast for the range query, while non-cluster is are better to extract the match of different columns. So how do you optimize the slow queries? Add indexing, limit the result sets, use covering index, rewrite the subquery join, and avoid select star from the every page, through which we can optimize our queries. Okay, limit the result set where clause before joining, add add indexes on the column where used in where join a clause by. Okay, what are and so let's move for the next question. So what are database transaction and the isolation level? So database transaction level or isolation level. Database transaction. Okay. Database transaction group a multiple operation into a single unit that either succeed completely or fail completely. Okay. Isolation level control how the concurrent transactions see each other's changes. Read uncommitted. Can read uncommitted change? Like dirty read possible. Read committed only read the committed data. Repeatedly read मतलब same query return the same result within a transaction. Same query return the same result. And this realizable. This means that strong isolation transaction run as if sequential. Higher isolation level prevent more problem but reduce the concurrency and the performance. Okay. Isolation levels are read uncommitted. Uncommitted mean can read uncommitted change. Read committed. This means only read the committed data. Default in the most of databases. Repeat table, repeatable, repeatable, repeatable read mean same query return the same result within a transaction mean a repeatable data read, and the serializable mean of strong isolation transaction run as a sequence. Strong isolation transaction run as a sequential. Higher isolation prevent more problem. So higher isolation. This means that isolation prevent more problem. Okay, more problems, but reduce the concurrency and performance. And so let's run our concept of concept of database partition. So database partition. So let's see database partition. What is database partition? So database partition is splitting the large table into the smaller one, more manageable pieces while keeping them logically as a one table. So splitting the data, splitting the big table, big table into smaller one, maintaining the tables integrity, okay. This means that splitting the large table into manageable pieces to keeping the logically in one table, logically in one table, logically in one table. So there are the four approach you need to know: horizontal partitioning, vertical and hash and range partitioning. So splitting the big table into smaller one and maintain the table integrity and logically into one table. How we reach how we through this how we achieve this process, how we achieve the data partitioning. So this can be achieved through the horizontal partitioning, vertical partitioning, hash partitioning, and the range partitioning. Okay. Through this, we can partition the databases. Horizontal partitioning split the rows based on the criteria dates like this. So benefit it include the faster query, easier maintenance, and better parallelization. Okay. Conserve data partitioning. Oh, so let's move forward. What deadlock? How do you handle the deadlock in databases? So deadlock. So next question is how you handle the data deadlock in the databases. Okay. So deadlock happen when a two transaction wait for each other to release the resources, creating circular dependency. So deadlock happen when a two transaction wait for each other to release the resources, so creating a circular dependency. And most of databases automatically detect the deadlock and kill one transaction. Okay, allowing the other proceed and kill transaction get rolled back and return an error. Okay. Here the strategy to prevent deadlock: access the table in the access table in same order across transaction, keep the transaction short, use appropriate isolation level, and implement retry logic in our application. So what is the purpose of database constraints? So database constraints. So let's discuss the database data data database constraints. Okay, what are the database constraints? So this means that database constraint enforce the business rule and maintain the data integrity at the data and database level. So it enforce the business rule and maintain the data integrity at the database level. Here are the four constraint types every database professional must know. So constraint all the professional have to know: primary key, primary keys, primary key. What do you know? Ensure the unique identification. So it ensures unique identification. Okay. After a foreign key maintain the referential integrity. So primary key ensure that the unique identification, and the foreign key refers to the referential key, maintain the referential integrity. Okay. So maintain the referential integrity. Okay. Check. After that we use check. Validate the data meet the specific condition. So check validate the data, simply validating the data to meet the specific condition. Okay, specific condition. Okay, specific condition. And after that, not null, not null, not null. Prevent the empty value. Prevent the empty value. Okay, and unique ensure and unique constraint. Unique, these are unique constraint help to unique constraint help to ensure no duplicate element. Ensure the no duplicate elements. Okay, ensure that no duplicates elements are there in this. So this is how it's practically used. So practically, so database constraints. So let's use practically. So let's see through the codes. So when we have creating a table, so what we like create create table name employee. Okay, employee having all the constraint. ID is integer type of primary key, must be primary key. Okay, after that email must be in varchar var of size 100, and here we use in database constraint unique, not null. Okay, unique and not null, unique and not null. Age int check age greater than is equal to 18, and age less than is equal to 65, less than is equal to 65. This is a check condition. Okay, and after that a department underscore id is integer type. Okay, and the foreign key is used to reference the another table's foreign key. So foreign key of department id, department underscore id referring references department of department by id. Okay, so through this code we use the database constraint. So constraint prevent the bad data from entering your database. Constraint that bad data to entering our databases and catch the error earlier before they spread through our whole application. Application. So explain the database replication and its type. So data replication is copying the data from one database to another database to improve the availability and performance and disaster recovery. So there are four technique: master slave replication, master application, and synchronized replication, and asynchronous replication. So we have no need to study this much. So what are the database trigger and when should you use them? So database trigger or database trigger are the special procedure that automatically execute in response to database event like insert, update, and delete. Trigger are handle for automatically updating the timestamp. So till now we cover all the intermediate question of the databases. So in advanced database interview question must be explained database trading and trade-offs. So understand the simply database trading split the large table into horizontal across multiple server with each thread contain only a subset of this data. Okay, and what is cap theorem? As we studied earlier, cap theorem that state that distributed system can only guarantee only two of the property consistency, ability, and the partial tolerance. Consistency means all node see the same data at same time. Okay, ability means system remain operational even the nodes fail. Fault tolerance means system continue despite the system continue despite the network failure between the nodes. So since only two of three are guaranteed, here are the most common combination. CA system, मतलब consistency and availability, like our traditional RDBMS, sacrifice the partial tolerance, they can't handle the network split. CP system like MongoDB certain configuration. CP means consistency and the partial tolerance. All nodes see the same data at the same time. Partial tolerance means system continue despite network failure between the two nodes. Cassandra is based on the AP systems. Sacrifice the consistency. Most modern distributed databases eventually consistent. They provide availability and fault tolerance while achieving a consistency over time. So AP is mostly used. How you design for the high concurrency? There is no need explain. And last, we have to discuss what is MVCC, multi-version concurrency control. So let's discuss a little bit about MVC. So what is MVC? MVCC. So what do you mean by MVCC? MVCC. MVCC mean it's mean like MVCC mean so MVCC mean allow multiple transactions to access the same data at the same time without locking by maintaining the multiple version of each row. So MVC mean it's allow multiple transaction transaction to access the same data at a same time at a same time without 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 locking. Okay, to maintain the multiple version of each row, to maintain the the multiple version of each row. Okay, so allow the multiple transaction to access the same data at the same time without locking, and to maintain the multiple version of each row. When you start a transaction, you get a snapshot of the database at that point of the time, and another transaction can modify the data, but your transaction only see the version that exists when you started. Okay, the benefit include the fact that reader don't block the writer, so writer don't block the reader, and consistent read without transaction. So how do you handle a very large data set and that do not fit in our memory? So one of the interviewer can ask this question in for follow-up question. So how we handle? So how we handle? How we handle very large data set? Very large data set that does not fit that do not don't fit in memory. So in this case, how we have to respond? So design a disk-based operation understanding how your database access the data first. Use partitioning, okay, Optimize the indexing, use cellular storage, implement a query result, consider data achieving different persisting. So what is database denormalization and appropriate? So read performance more. So read the performance is more important than write performance. There's a primary replica, one replica, two. So explain database connection pooling. There is no need that much of. So there is a behavior and scenario based DMS question. These questions just evaluate your problem solving skill and experience working with the client and data terms. So behavior question, behavior and scenario based question, based based DBMS question. Okay. So these questions evaluate the problem solving skill and the experience when the client and data stem. Interview just use the behavior and scenario question to see how you handle the real world database challenges. They want to understand your thought process, communication skill, and ability how to work on the non-technical fog when the database issue arises. So the first question maybe tell me about a time when. So let me write question and then we explain. So tell me about the time when you tell me about the about a time or time when you had to optimize a slow query. So this is was the first question. Now what your approach? Structure your answer to start by describing the problem and the impact. Our customer dashboard has 45 seconds to load because the main query was doing a full table scan, a millions of rows and table. This was frustrating even when the causing then abandoned the page. These type of question describe situation when you had to explain the complex databases to non-concept to stakeholders. Pick a specific example, like your marketing team was frustrated that their customer segmentation report to took 20 minutes to run. Instead of explaining the databases, join and indexes, I was simply analogy. Describe your communication approach. I told that imagine looking a customer who brought both product A and B, and the current system was like manually searching through the each recipient by use filling cabinet. All these are just read once through ChatGPT. So till now we think that we cover all the question. So that's all. Everything is covered. So in the for tips, final tips, how we prepare, tips for preparing for interview, tips for interview. So we have to practice the SQL real life data sets and set a database environment, study the real performance and the practicing the database design, review the both SQL and non-SQL approaches, prepare a story about databases problem. So stay current, updated to trend. So DBMS tests everything of the basic SQL syntax to complex design and to ace this master fundamental concept, normalization, indexing, transaction, then tackle the advanced problem like threading, high availability design. Theory alone isn't enough. You must have to connect the database knowledge to real world application. So when you explain the indexes, mention how they reduce the query time from the minute to second. When you describe the replication, explain how it prevent the costly downtime. So alongside SQL and DBMS, it doesn't hurt your preparation skill.